Welcome to Air 3 and pressure. So today we're going to be learning about pressure. So what is pressure? Well, pressure refers to the force over a given area. So it's the space that goes along with it. So how much weight are you pushing down, or your force over a given area? And so we use a formula right here. Pressure equals force divided by area. Would you rather? A great game to play that has awesome questions that allow you to really think about what you would rather do. So, if we know that pressure is force divided by area, would you rather have an 180-pound person or a 110-pound person step on your foot? Not a difficult question, right? Personally, I would rather have a 110-pound person step on my foot. Ouch! But the second question here, what if though, say that 110-pound person, what if they were wearing high-heeled shoes, these little fancy shoes right here? Would you rather have that 110-pound person step on your foot? Think about that one a minute. So hopefully you had a second to think about which one you would want. Personally, I would go back to that 110-pound person, because what do we know about those high-heeled? They have a small area. And if we were to divide out 110 pounds divided by that tiny little area, now we have a lot of pressure being pushed down in that small area. So what is air pressure? We hear about air pressure all the time when it comes to the weather. What air pressure is these gas molecules exerting pressure on their surroundings. So think about the gas that we have out in the air. That gas molecules are constantly pushing on everything around them. So air pressure can come in different forms, high or low air pressure, and they come in different units. You'll see it measured as PSI, which stands for pounds per square inch. You often see this one on your bicycle tires or your car tires. mmHg refers to millimeters of mercury, and that goes back to a barometer that would have mercury in it. As that barometer changes, that mercury would rise up or fall a certain number of millimeters. ATM refers to atmosphere, and the torr refers to the person who discovered that term. So 4 different units that you will see commonly referring to air pressure. So the units that we use for air pressure, we know that the formula is pressure equals force divided by area. We would measure our force in what are called the newtons. I know you use newtons quite a bit in physical science or physics first to measure force. Area, when it comes to chemistry, is measured in meters squared. So if we look at our force, our newtons, divided by our area, meters squared, we would say that that unit for pressure is the Pascal, or the PA. So let's ask a question. What causes air pressure in a tire or any sealed container? We said that air pressure referred to those gas molecules colliding with their surroundings. So if you've got a closed container, so make sure you draw this box on your sheet and draw all these little gas molecules in here. We know that gas molecules are spread apart, and we know that as they're spread apart, they're going to run into one another, and they will also run into the sides of the container. So air pressure is caused from the air molecules moving and bouncing off the sides of the container. These collisions then exert a force on the walls of the container. That is our air pressure. So how do we measure air pressure? We typically use what is called a barometer. A barometer has the mercury in it that we talked about, millimeters of mercury. And you can see you've got a container with mercury in it and a long glass tube. As air pushes down right here onto the container of mercury, that mercury gets pushed up the glass tube and it rises up a certain number of millimeters, inches, or feet. There's all sorts of different kinds of decorative barometers that can be used that would hold water instead of mercury, and you can see the changes as it rises or falls based on high and low pressure weather systems. So we've got some typical air measurements at sea level. So if you're down right at sea level, we would say that pressure is at 101.3 kilopascals, or pressure is considered 1 atm or 1 atmosphere, and it's also 760 millimeters of mercury. So let's watch this video that talks a little bit about air pressure.
Pressure is always pushing on us from all sides, about 15 pounds of pressure for every square inch. But at the same time, our bodies push back against the air pressure with equal force, so it balances out and we don't get crushed.
I wish I could see all this.
Well, think of it this way. Picture air molecules near the ground as being packed tightly together by the weight of the air above. This is why air is much denser at sea level. But higher up in the atmosphere, there's a lot less air pushing down from above, so the air molecules are not packed together so tightly. Normally, we don't feel any of this unless the pressure changes suddenly.
You mean like when your ears pop in an airplane?
Exactly. At much greater heights, there is less air weight pressing on you. Your body is reacting to the pressure change.
So that gave a little background information about air pressure. So if we were to look at the air pressure here in Osseo, Minnesota, the Earth's atmosphere has a force of about 15 pounds per square inch, or PSI. So if we had a 1 by 1 dimension object, which is 1 square inch, and we know that we have a force in Osseo of 15 pounds, 1 times 15 gives us 15 pounds per square inch. Now, as we see, if we did 2 times 2, we'd have an area of 4 square inches, and 4 times 15 would give us what? 60 pounds per square inch. So take a minute, pause the video, go through and finish your dimensions that you have on your notes, and you'll see what happens as we increase the size of a given area. What happens to the amount of force or pressure that we have hitting down on us? So going back to how we calculate pressure. Calculating pressure, we use the formula force divided by area. So the first question that we can work on is calculate the pressure of a block that is exerting a force of 18 newtons that has a measurement of 0.25 meters by 0.5 meters. To start this one off, we need to identify what is 18 newtons. Is that my force or is that my area? And what is 0.25 meters by 0.5 meters? Is that my force or my area? And I have some math calculations that I have to do. So pause the video, set it up, and make sure that you get the answer and check it with your teacher. One last question for us to solve for before we turn you loose on your own is what pressure is exerted by a block that weighs 25 pounds and is 3 inches by 5 inches. Begin by identifying your force, then identify your area, set up your problem with force divided by area, and solve and check your answer. Take some time to practice the other questions on your sheet and check your answers with your teacher.